the technical architecture of the Xandeum blockchain. Let's dive into it today, and I'll show you all the details. I'll show you the diagrams that we created, and the goal of this video is just to walk you through so that you get an understanding on how the Xandeum blockchain is working, how it all works, how we build on the Solana blockchain, how we make everything scalable, including that scalable storage layer. So this is a little bit technical, but don't worry, I'll guide you through all of this. And if there's any questions or so, there's always the comment section. You can comment down below. Don't be afraid. I'll be here to answer all of your questions. And also, I'm very interested on what you think. I mean, there might be some people in the audience that have a different view of these things, and I'd love to discuss them right in the comments. And yeah, let's dive right into it. And let's look at, not this, oh man, where's the technology? Let's look at this. All right, so here's the diagram, right? And everything starts here with a transaction, right? So we have a transaction here. So you have an app, right? So think about any app that we're building, let's say a Web3 version of some of your favorite Web2 apps, right? Let's say a Web3 version of eBay, right? So then someone submits a bid, right? Or someone uploads a photo of their product that they want to sell on eBay. Those are all transactions that you see here. So, and transactions usually in Solana are, coded in the Rust language. So we gave some FN here for a function. That's a Rust function. Swap, for example, a function, pay fee, things like that, right? So some sort of front end that has some nice GUI that you can see on the web, right? You go to that Web3 version of eBay in your browser, you see a GUI that looks similar to the Web2 eBay that you already know. And then once you do something there, you submit a bid or you list a product or you upload a photo, that's where things happen in transactions, right? So these transactions now, they run code, but they run code on storage, on what's called accounts on Solana. So you see the account struct here, and here in the dark orange, we have the Solana accounts that we all know. That's the storage that's built into Solana, and it is just the storage layer in Solana. I mean, Solana is a super scalable blockchain. That's why we picked it as our code base. But the storage is not scaling. You cannot store terabytes of data on Solana unless you fork over a couple of $1 billion, right? So it would be something for Elon Musk or anything, but not for the normal user. So that's where Xandeum comes in, because we are building that a scalable storage layer, and we call that eggs, which is the external global grouped storage. So that's our scalable storage layer that we're adding on top of the regular accounts and code layer that's already there in existing blockchains. In our case, we use the Solana code base as mentioned. So these all account structs, right? We are changing the Solana runtime, right? So usually in Solana, we can only pass these Solana accounts, but with Xandeum, we can pass these eggs accounts here. And these eggs accounts don't live in the validators, right? The dark orange ones, they live in the validators. In each and every validator, the storage has to be made. And that means that it is just you cannot pay for it because it's so expensive. So let's go back to our diagram. So we are changing augmenting the Solana runtime, right? The program runtime. And Solana is working on a new version of that program runtime. It's the PR 2.0, the program runtime 2.0. It will support the Move language natively. So we're waiting for that to happen so that we can jump on that train as well. And we have here in magenta, no, what's that color here? Cyan. We have the eggs accounts, right? And those can be passed in as well. And as you see, since usually we only support the Solana accounts, we have to augment the Solana runtime. That's what we're doing right now, and it takes a little bit. Give us some time to code all that and to dive into the details of the Solana code and adding our stuff there, right? So with these account structs, the transaction will be sent to the validator. So it goes to the Xandeum validator. All these accounts here, the Solana accounts, right? They are in mmap, right? So mmap stands for a memory mapped file. So that means all of these Solana accounts here, they will basically be stored in RAM. If there's more accounts out there than fits in the RAM, then it will go into a file, but that makes things super slow. And so basically, all of these accounts have to be kept in RAM, in memory, which is kind of the most important thing we can have in the whole blockchain. And it has to be on each and every validator. We have 2,000 something right now on Solana. Maybe next year we have 10,000 with FireDancer and everything. 10,000 validators need to keep the accounts all in RAM, each and every validator. That's why it's so super expensive to keep large amounts of storage there, right? So with our eggs accounts, these go to these external storage. This is a delegated storage. That storage does not live in each and every validator, right? Our egg storage lives in storage provider nodes, right? So we have lots and lots of storage provider nodes that run on cheap consumer hardware distributed all over the world, right? So we aim for tens of thousands of storage providers when we launch our DevNet, and we need hundreds of thousands and eventually millions of storage providers all over the world. And that's going to be a nice endeavor for a lot of people that just have storage space, hard disk space lying around, and they can make money off of it and earn Xan tokens off of it. So yeah, these storage providers, there will be a lot of these, right? So then we have that eggs manager here inside the validator, right? So all these storage nodes are being supervised by the validators, right? But we don't need to store all this storage. So this storage is scalable, right? We can store a terabyte, and it doesn't have to be replicated 2,000 times, 10,000 times, how many ever validators we have. And it doesn't have to be kept in memory either, right? So this is just stuff that that can live in those storage providers, and it can live on the disks, on the SSDs of these storage providers. It has to be SSDs, though. There's no support for spinning disks or stuff like that. It is just not doesn't have enough endurance, and it's not fast enough. We still want to have fast storage here. It won't be as fast, though, as the Solana accounts, right? Because that's going to be kept in memory in each and every validator. So that's the fastest kind of, tier 1 storage that you can have. But as long as you have large amounts of storage, you just have to go to that tier 2 storage that we're building here. And it's delegated out to all these storage provider nodes. And we are managing all these storage providers from the validator code. So all this cyan boxes here, and it will be added by us. So we're working on creating that eggs manager. We already have coded most of the eggs provider registry. It is all permissionless once mainnet starts, so anyone can run a storage provider permissionless. And as soon as you register, you will be monitored by the validators, and the validators will make sure that we store the data redundantly. So you will have, when you write an app, you will have the opportunity to make a choice. You can say, okay, I want a redundancy of like 17, or I want to have a redundancy of 43, right? So that just means if you have a redundancy of 17, that just means everything's going to be stored on 17 different storage providers. They are all being monitored constantly by the eggs manager in the validator, in the validators. And if the validators find that one of these storage providers is not reliable, they just swap it out, right? And if someone's not reliable many times, he will be, that storage provider will be fired, so to say, right? So we'll kick them out and never assign storage to those guys again, right? You can tell with a redundancy of 17, that's enough for many, many, many scenarios, right? But this parameter will be tweakable, right? So certain apps need higher redundancy, and they can just request a higher redundancy. And all the data will be sliced as well, so and of course encrypted. So none of these guys that actually run a storage provider will be able to decipher anything that's being stored there, but they will be monitored constantly. If they do what they're supposed to do, we will use a modified version of what's called proof of space-time. So we will not only send them challenges from time to time, like, hey, are you really storing? Can you really retrieve what I asked you to store? Those are the challenges that we send here from time to time, but the challenge will also contain cryptographic proof that it had been stored all over that period of time since the last challenge, right? And there will be proof of replication, so we're making sure that we cannot do Sybil attacks, right? So what we don't want to do is like have one guy that poses as 50 storage providers, right? And only stores at one time. And then someone thinks they have a redundancy of 17, but in the end, this guy is all one and just stores it on one disk. And if that disk fails, then all the 17 copies are gone, right? We prevent this kind of stuff through our proof of replication. So this is all technical stuff here, cryptographic stuff. So we do the proof of replication, we do the proof of space-time in a modified version, not the proof of space-time that's done by some other chains, like, for example, Chia and many others that kind of write patterns to the disk all the way around just to make sure that the whole disk is dedicated to that chain. We're not doing that. We don't want to, wear down your drives in no time. And yeah, so then we create zero knowledge proofs that these storage providers have actually done their job. We log the zero knowledge proofs to the underlying main blockchain, which is basically the Solana blockchain, but just our fork of it. That's why we chose Solana as the base blockchain, right? So and then we have an eggs cache, it must be here, and that's an ARC. It's called an adaptive replacement cache. So that's the latest cache technology, state of the art that we're using there. We already have much of this here coded, and we're working on this here, and we're also working on the software that runs on the storage nodes, right? In the last email for our email subscribers, we already sent a sneak peek, right? A little screenshot of how the Zand miner, that's the piece of software that's running on the storage providers, how that looks like, how the GUI looks like. And yeah, I just wanted to say there is so many bits and pieces here that we're building right now, and it can take a little while. And I just cannot make tough timelines here, because what we're doing here is something that hasn't been done before, right? It's not like we're building a bridge where thousands, maybe millions of bridges have already been built in the world, and we know exactly how long it takes, depending on what team size it is and stuff like that. Here, there's lots of research involved, right? So that just means and especially there's a huge code base there. The Solana code base out there, it's all written in Rust. Much of our team, all of our team is very familiar with Rust, including myself. So we are diving into that validator code. And also we are looking into the Fire Dancer code, which is the new second validator code for Solana, which is way, way, way faster. It's written in C and C++. It's my programming language from the past, also very familiar with that. So we're looking into that as well. But priority right now, obviously, has the Labs client, the Rust client. And we're having early versions of our stuff already running in our DevNet. So super happy to have 60 nodes now in our incentivized DevNet. Thanks everyone for participating. It's a huge, huge number. I'm so happy that our community really wants to run these nodes, right? It's not like they only want kind of to participate or, make a quick buck or stuff like that. They really want to walk the walk, right? And not only talk the talk. And I am so super thankful for that community. And, thank you everyone that's part of that. And thank you, Brad, from our team, helping manage that DevNet. And so I hope you like this overview. It's a little bit of a sneak peek on what we're working on. As I said, tough to commit to any timelines right now. But we hope to have, some sort of new versions out like every few weeks, and we hope in a few weeks we have some more progress to show, and then the new version is there and you can download it and install it in your DevNet. If you don't run a DevNet node yet or don't own a Xandeum node yet, right? So we have that concept where we are selling nodes in order to fund our development. That is a validator node license, right? It's not a storage node license. And if you don't run a validator node yet, nodes are for purchase, right? And there's only one node left for the current price before the price goes up by another $500, right? So go to Xandeum.com. The link is down in the description. You see it here as well. Xandeum.com, and there's a big button in the top, Get Node. So really, if you want to get into this exciting new venture, I highly recommend getting a node. If you still want to participate in DevNet, there is a 2x rewards boost if you actually run a physical DevNet node for the duration of that incentive. And if you do that right now and nodes are coming in, you can just ask on our Discord, and you can join our Discord on Xandeum.com, and in the top right corner you find the Discord link. Join our Discord. You can ask there to get that 2x boost. It was actually only for the launch of the DevNet, but hey, this was a deep dive video, right? So if any one of you finds that so exciting that they want to get a node, you can still get the 2x rewards. Just reach out on Discord and we'll get that 2x rewards for the incentivized DevNet done for you, right? So yeah, I would love to see lots of comments down there. And please also hit that like button. It is super important for us. It really helps me out. Thank you in advance. And leave me that comment so that we can discuss anything for our strategy, for the architecture and everything. And for today, thanks so much for listening. Catch you guys later. Peace.